to talk about some of the work that we have been doing in recent times with a fairly high degree of confidence that by 2030, India should get 50% of power from solar. The reason is, if you look at the sources of power, the sources of power that India has is coal, does not have oil, does not have much gas, does not have even nuclear fuel, hydro is by and large saturated. The growth is either going to come from coal, which all of us know is polluting, or from renewables like solar and wind. And a target that India should get 50% of power from solar is what I am going to talk about and what role it can play. There are a large number of colleagues who have been working on some of the work that I am going to present. Some of them are listed here, about a team of about 150 young people who are working and doing this work. Just to give you a certain background, as I do, as we start, I don't know how many of you know that in India there are 250 million homes, 1/5 of the homes, 50 million homes are still not connected to the grid. Numbers have been declining, but not as rapidly. The second is about 100 million homes have load shedding anywhere from 2 hours to 12 hours a day. Particularly as you go to rural areas, the load shedding increases. So you have a 2-hour to 12-hour load shedding in most parts of the country. There are parts of the country where things have improved. In recent times, there has been some improvement, and there is a certain amount of power surplus. So what I expected is when there is a power surplus, probably load shedding will go away. But I think the third important reason that 50% of India's population cannot afford power, even at the subsidized rate of 5 rupees per unit, is a very, very crucial thing. And that is what causes a problem, because at 5 rupees per unit of electricity, and unit of electricity is 1 kilowatt hour, Discom by and large lose money. And still, most of our population cannot afford it. That's a big dilemma. And how do you really go about doing it? How do you power India? How do you ensure something like that? And it is in this context I am going to talk about the whole solar work that we have been talking about. I'll start by a simple story, which yesterday also a group of people that I met, I told about that. Last year in December, Chennai had one of the worst floods. Most of you must have heard about it. 4 days the city was inundated with water. 4 days there was no power in the city. IIT also did not have any power. First day some places had power because there was some diesel generator backup. After that they had all disappeared. My home, without our realizing what we have done, we have set up an experimental system there. And my home had power continuously for 4 days. I had my tube lights on, 1 or 2 tube lights. I had one fan on most of the time. I had TV on for very short periods of time. But most important, I was charging and discharging my laptop. I was working for those 4 days. I was alone at home, nothing much to do. You can cook and eat and then work. That's all that you could do. And I was charging, discharging my laptop. I was charging my cell phone again and again because it was going out. In fact, people around used to also come to me and say, get my cell phone charged. Now, what was very surprising is that I had not anticipated. First of all, we had not anticipated the power will go off for 4 days. And I had not anticipated that my system could last for 4 days. My system had a solar panel which was 125 watt, which is as big as from here, roughly about this big. That solar panel costing about 5,000 rupees was up on the rooftop. Remember that there was not that much of sun. The day after the storm and the flooding, there was practically no sun. The third day some sun came, the day after some sun came, but also mild sun. And I had a battery, but it was a 0.5 kilowatt hour of battery. So, first few hours I said, well, it doesn't matter. But beyond that, I was all the time worried. So I was worried and trying to even conserve power. But how did a 125 watt hour of solar panel and half a kilowatt of solar battery could give me enough for the 4 days. 2 tube lights, bulb, a fan, laptop charging, cell phone charging. I actually did all of the calculations and found it difficult to add. And it is at that time that I started looking a little bit more carefully. And what we had built was a solar DC inverter. What we had done was not just solar panel, but we had also done one more thing, that we had decided to put a DC wiring in my home. And the DC wiring, what did it actually do? We didn't understand as well till that incident happened. We had some theoretical knowledge, but what it can do. Now, I remember sometime back, we had proposed this, about 2.5 years back. Me and my colleagues had proposed that if you are doing solar, we should do also DC wiring. And my own younger colleagues, I remember, used to walk by my room, look at me as if I had gone senile. Not something that was unusual, because when we are starting to replace wired line by wireless, and we'll say wired telephone line will be replaced by wireless, everybody had called us mad. Nobody in 1993-94 believed that wired line will be replaced by wireless at a particular time. But we actually did it. And only today people don't even understand that why there can be a question on wireless line. And at that time people used to sort of look at the young people. I don't think the young professors, something has gone wrong with them. At best they may humor us. Some of them of course will put obstruction. We have faced all that. We have faced lots of trouble in actually making a difference. Basically going away from a standard way of doing things. It's again, back in 2014, we are starting to do something totally crazy, saying we want DC wiring. And the first thing that people pointed out is that this whole thing has been settled in 1890, not 1890, not 19, 1890. There was a big battle between Tesla, who was for AC, and Thomas Edison, who was for DC. And in that battle, it was a very dirty battle. It was actually a battle between two corporates. If you look back, you don't see that the truth was with either of them. But they were made it as if it was a scientific battle. But finally, AC won because of some scientific reason. Because there was a transformer that was invented at that time, which allowed the voltage to be increased and therefore current to be decreased as you do long distance transmission. And as you reduce current, the losses can decrease. And that helped AC get the foot in, and it virtually finished off DC. And from that time, by and large, the DC had disappeared. Took some time. In India, we had it as late as 1955. Some places, people had installed it. But by and large, AC had won. The R&D started in AC. Everything else started in AC. The protection, everything. R&D on DC virtually stopped. Nobody really thought of that DC wiring will be brought back in the world. And yet, when we started looking at solar, we came across some facts. The first fact was that as we started working, we had a very simple system to begin with. This was actually introduced to me by one of my colleagues. These were existing systems. There was a solar panel, and there was a system to which it was connected. Solar panel produces DC power. It does not produce AC power. So the DC had to be converted to AC. For large panel, the losses are not that much, 3 to 4%. But if you take a panel which is 100 watt, 200 watt, the losses will be 12 to 15%. The first time I heard that, I said, why should the losses be so large? Why can't we design something better? And my young colleagues that time sort of said, well, we can design something that will pay 5 times more or 10 times more, and maybe we'll bring down the losses to 10%. But if you want something affordable, it will be 15% losses you have to accept. And all the systems that are being deployed, 15% losses are acceptable. And then actually you connect it to the grid AC and the solar AC is then combined. But associated with that, there is always a battery. because solar power is not constant. And therefore, and the battery also stores only DC energy, charged by DC, outputs only DC. So you have one more AC to DC converter, and then a DC to AC converter. So in fact, when the power goes from solar all the way to the load, it passes through 3 of these converters. The minimum losses in these converters comes out to be 45%, plus the losses in the battery. And we actually took systems. We took 15 systems that were being sold in India. We did the measurements, and everywhere the losses were 45% plus. So what are we doing? We knew that solar power was expensive, and we are losing most of it before we start using it. Is it meaningful? Can we do something different? It is at that time we sort of said, well, why can't we look differently? And we are helped by one more thing, that we of course were generating this AC load, and we sort of said, well, AC will power our lights, fans, and every single thing. But we started looking at the loads. What is happening to the loads? The first change has taken place in lights. The lights were becoming LED. It was obvious that LED lighting is so much superior compared to conventional lighting. But what is important is that LED lighting is DC power. So if you have AC, you have to do one more AC to DC conversion. So in fact, in the lighting, there was one more conversion. And depending on whether you will do power factor correction or not, there can be again 10 to 50% losses. But of course, LED lighting was very superior. It consumes much less power. It consumes only 15 watts. And you could also dim it. It could consume only 4 watts. In fact, in those 3 days, very often I was using the dim light, because when I was not eating or not reading something, I could easily dim the light. So the lights basically require DC power. What about the fan? The fan that we use, this fan typically consumes about 72 watts of power. It's a typical AC fan, consumes 72 watts of power. And when we started working, some of my colleagues told me that if you can make this instead of induction motor AC fan, if I can make it with a brushless DC motor, I can significantly reduce the power. And we started working with Compton Greaves and TBS Lucas. We made the fan, looks exactly like that. You don't even know that there is a DC motor inside. And it consumes only 30 watts. And when you dim it, it consumes only 9 watts. But the important thing is brushless DC motor fan is a DC power. You need only DC wiring, DC power. So if you are going to use AC, you have to do one more conversion. Well, this was lights and fans. What are the rest that we use? Electronics, television, laptops, computers, cell phone. All electronics. This one we knew, even though we were not part of power systems, that these are all DC. And everywhere you have to put a converter. So I had a HP, very expensive laptop, bought the converter from them, I measured the losses, 33% losses. I had a Nokia cell phone charger, measured the losses in that, the AC to DC conversion, 50% losses. Of course, I challenged the Nokia people. Even so, I said, well, it consumes so little, how does it really matter? The point is, it doesn't matter if it is one cell phone, but there are 900 million cell phones, it does matter. Where everything just is waste. They're wasting so much power. So all electronics, and everything is electronic, every sensor. In fact, we go to a room of this size, our office room of this size, there are about 100 sensors today. All kinds of sensors. Every sensor is an electronic sensor. Every sensor only takes DC. Everywhere there is AC to DC conversion. In fact, in one of the offices of this size room, we found more than 100 AC to DC conversion. Each of them has costs. Each of them is a point of unreliability. Each of them is losses. And it's not just this. Even the refrigerators, washing machine, the new ones come. These ones that Sachin Tendulkar often advertises, this inverter-based refrigerator, inverter-based air conditioners and all that. High efficiency. They're all running DC motors. And therefore, if I look carefully, all the reason that we defy the tradition and say why not have homes and offices which are DC powered? Well, one gentleman has already installed AC. Fine. But we are building also fairly rapidly. In next 15 years, we will probably build as much as we already are having. So first of all, new buildings we should have, of course, use. Second, very often we do all kinds of retrofitting. Most homes have the inverters at their home and they do separate wiring. Why not use DC? And we sort of said, if we can do DC at both homes, offices, commercial complexes, industry, of course we need to standardize voltage. That's the first thing that we need to. It's not as simple otherwise. For low power, we actually work with several IITs. 48 volt becomes the best. This is safe voltage. We wanted to in the beginning have safe voltage. On AC, a lot of protection devices are developed over time and become very inexpensive. On DC, as of now, they are not developed. In future, they can be developed. Nobody says they cannot be developed. So you want to start with safe voltage, 48 volt, below 60 volt, which is considered safe. Something that a telephone wire anyway brings 48 volt. Why can't we use something like that? One considered lower voltage, 12 volt, 24 volt, except a 24 volt wire will increase the losses by 4 times, because the current will go up by 2 times, losses will go up by 4 times. 12 volt wire, the losses will go up by 16 times. Makes no sense. So you want the highest possible voltage, but safe. And 48 was obviously. Of course, for higher power, one can consider a better voltage, higher voltage, 380 volt DC or something like that. One is moving towards 48 volt and 380 volt. But for 380 volt, we need to have all kinds of safety and precaution. And then one can have what I call a solar DC system. Completely DC. Solar produces DC, you put DC. Grid, you convert AC to DC. Grid is AC, convert AC to DC. Battery is DC, keep it DC. Connect it to the load. And current DC appliances without that converter. Why can't we do that? What does we do? From when power is coming from solar, that 45% by and large we have eliminated to almost 5 to 6% losses. The design is not as straightforward. Of course, it's a highly efficient use of power because the solar power is not constant throughout the day. What is called a maximum power point, so it keeps on varying. So we have to have a range between 48 plus minus 4 or 5 volts. Battery is an independent element and requires charging at its state of charge. Depending on state of charge, is not constant. Load is at some fixed voltage. So you still require voltage differentials. And if you want to put converter, DC-DC converter, once again the losses will become as high as an AC to DC. May not be as high, but almost as high. So design becomes fairly complicated. How do you really design something such that the losses do not go up? And we were able to design, instead of 45%, losses become 5 to 6%. Some complex design, but again, this is where a bunch of youngsters matter a lot. They work 14 hours, 16 hours, they fail, they make mistakes, and then somebody will come with a new idea, and somebody will come with a new idea. And it takes us some prompt time before the whole thing is done and you make it and commercialize. So today we have a system called inverterless. This is what was installed right now. Inverterless, all of us who are familiar with inverter, this is inverterless because there is no inverter. But it does the same function. It connects to a solar panel, anywhere from 125 watt, 250 watt, 375 watt, 500 watt. AC line can come in, 30 volt AC, up to 500 watt. It has a battery. And we did something fairly good with the battery, but I'll skip battery. Interesting. But output is DC power, up to 500 watts. And believe it or not, I have a 3-bedroom apartment. I went to Mr. Raju Sagal's house yesterday, and all his requirements, I don't know, I didn't see air conditioner, rather than air conditioner, can actually be met by the 500 watts if you use DC. All your house. I saw it yesterday. So, very large house, not a small place. My own apartment, 500. Maybe somebody may require, even larger one may require more. You can put 2 such systems. And what is more important, smaller homes, 1 bedroom, where 20% of our population live, 30%, 35% could actually benefit tremendously by something like this. We actually built this. Of course, we did all kinds of tricks. For example, one of the very important things that we did, and I'll talk a little bit more about it as we move forward, is since we are designing this in 2014, we put a Bluetooth. We wanted it to monitor. Of course, our first interest was to put a modem. But modem would have become expensive. At least 1,000 to 1,500 rupees. Our unit itself, we are trying to make it at 3,000 rupees. So we can't add that. We could add Bluetooth things. And almost all homes have cell phones. So cell phones could communicate with that, get all the data, and upload the data on the cloud. So you still get all the data on the cloud, but through the Bluetooth. But what was important, we are going for DC. Means the new appliance that is available, which is DC. So we had to work on LED bulb. Well, we could design that. We had to create charger and sockets, chargers. If you look at it, it's not very clear, but if you look at it, if you see the connector is like this, one line like this, one line like this. Why? Because DC has this polarity sensor. You can't put it the other way around. You put the other way around, you're going to burn something. So you have to make it one line horizontal, another line vertical. Two terminals. And even that we have to design. It is not available. You have to design and you have to make it low cost. Everything you have to commercialize. Because if you don't do that, your system is not there. And if you make it expensive, nobody is going to use it. And you don't have volumes to begin with. This is a big challenge. And yet, if you meet that, that's where the influence comes. Fans, fortunately, we were able to convince TVS, Lucas, and Crompton Reach to work with us. And they made fans. Tube lights, we got some company to, each thing we got some company to work with us. And of course, since we're designing this again in 2014, we built it a remote, very nice remote which can just control every single thing. It doesn't cost all that much extra, and that's an extra feature. Today, at 20,000 rupees, a solar panel with 125 watt, a battery which is 1 kilowatt hour, only 50% of that can be used at a time, 500 watt hour. A fan, a bulb, a tube light, a socket with a USB cell phone charger, all this inclusive cost 120,000 rupees. You install that, you essentially, in a small apartment, you are given life. Power will be pretty much one day. You have a grid, connect the grid to that. That will give you even stronger. Doesn't cost all that. And we did this. We of course went and did further. We designed a desert cooler, a typical desert cooler used in dry climates, can't be used in Tamil Nadu. But 200 watt is a typical desert cooler, 180 watts. We designed something which consumes about 80 watts. What did we do? Simply use a brushless DC motor or SR motor. Television, we had to get the inside is all DC. The connection DC part was not coming outside. We went to the manufacturers. They initially sort of said, no, we can't take it out. Then we sort of said, what will it take you to take it out? So give us an order for 100 numbers. We gave them the order for 100 numbers. And they took the software. And then we started buying more. And they said, sir, if you could really standardize this and make it widely available, it will bring down costs significantly. Because 93, and this was Sony's statement, 93% of our failure in India is in the AC to DC converter because of line voltage variance in the country. It will save less cost, it will save power. They knew that their losses were around 23%. They had a loss of around 23% in the Sony system. And we then designed a DC mixer. And this time we did one more interesting thing. We went away from brushless DC and we designed this with switched reactors. Those of you who are in power electronics will know that switched reactors motor is more difficult to design. It could be noisy and complicated. 3 years back when I started working on it, my colleagues sort of said, sir, BLDC will be able to help design switched reactors motor. And we designed all earlier things with brushless DC. Only to actually found out that there is a very important element that is made out of permanent magnet. It could be a ferrite or a rare earth element, neodymium. That element is only available, that material is available, 90% of its mines are in China. And they have a China controlled price. They actually brought down the price like anything about 4 or 5 years back. And in fact wiped out all the mines in the world. And then pushed up the price. And tomorrow they can push it more. We're not very comfortable with that. Then somebody told me the switch reluctance model, which is more complicated, will not require a permanent magnet. It will require a steel which is made by SAIL, and it is made by 2-3 other companies in India. And it requires quad, and the rest is electronics and software. I said, we are good in electronics and software. That's what we do. Why not get on this? We put together a team, took difficulty, we designed a motor, not 4-port, and we are able to do that, reduce the sound practically similar to BLDC, and we are able to design that. And today we are sort of saying that is the future for India. Our induction motor will gradually be replaced by SR motor. I think even for our boards, we should actually consider switched reluctance motor. And we have not designed it. Now we are making those designs for electric car. In fact, we are involved in designing electric car. We are doing that. We are designing for motors, for atta chakki, for all kinds of things. And I think it's a more complicated design. But then, and more complicated software. You are actually shaping the magnetic field. You are doing signal processing in actually controlling the magnetic field instead of controlling the electrical signal. I think we have knowledgeable team. And we work hard, our youngsters are there, we should actually do that. And we can make each of these things we make, be commercialized, and we're able to make that possible. And then we are ready to kind of try. Fortunately, Government of India sort of said, there are deserts in Rajasthan, border of Pakistan. Look, and they are not, there are homes. They are not having grid. Can you go there? Very often, they are in no man's land. And we actually we're not sure whether they are in India's borders are such as. We went and started installing. Very tough terrain. You can't take a vehicle. Trucks can go. Sorry, not trucks. The tractors can go. And camels can go. We went there and 4,000 homes were able to. And now we are going to Assam, on the hills of Assam. Again, nobody wants to go there. 7,500 homes. And it's just expanding like that. The whole thing has been installed in a very big way. What is most interesting is the monitoring feature. In the beginning, when we installed the system, we thought everything was working well. At my home, at lab, everything will work. It didn't work well. If we didn't have the monitoring, we would have installed and forgotten about it. But since we are monitoring, we are getting data every alternate day. We say, well, it's not behaving the way we anticipated. We went and corrected it. It improved. But again, it didn't work as well. And we again worked on it and corrected it. Monitoring becomes a very, very powerful tool in innovative design. Monitoring is key. And today we are doing all kinds of things. Train local technicians to actually do the thing. Empower them. And we are installing left and right. And as I pointed out, that aim was to reduce losses. Are we getting reduced losses on the field? And I think this is where the monitoring helps us. In the beginning, we found the losses were not low. Then what are we doing? Just because the system is working, that's also not good. We actually have been able to go and shave off every 0.5% of loss. Very difficult because my team sometimes said, sir, only 0.5%, how does it happen? But जो कहानी है ना बूंद बूंद से सागर बनता है वही that every 0.5% adds up. And if you are a good designer, will worry about all these things. And I think we have to be determined that we are going to make a system superior to anybody else. That's what is going to make us go forward. Need to monitor the system, diagnostics, require connectivity, and as I pointed out, we did it through the mobile phone. That's the only way we could bring down the cost significantly. And we are monitoring. We are getting, for example, curves like this. Sometimes, of course, it's very, very fascinating because the kind of solar that you get, every few minutes we do that. In Rajasthan, for example, it's absolutely flat. No, not even a cloud. And the amount of load that you do over 24 hours, the power that is going into the battery, coming out of the battery, monitor each one of them, and figure out how the waste is being done and improve it should be done. We also brought in monitoring by customer. That was important because getting them involved, get their cell phone, they are able to see for themselves what is actually happening. And we are working also, by the way, in Sasaram. And we are finding same kind of difficulty out here. Yesterday we went there. And those again, monitoring will really help us get things. What is important is that this is not for the off-grid home. This is for on-grid home equally. My home was on-grid. In fact, it gives me three things. First of all, it gives me 24/7 power availability, helps me to avoid wastage and conserve power. Now, of course, villagers are thrilled. I can play movies, I can do various things. But I think if any one of you are interested, one, come and see it. IIT Madras. Number two, if you want to go to Rajasthan in those villages, Jodhpur district, Jodhpur Jaisalmer district, you can kind of facilitate. Really worthwhile visiting. Remember that our motivation was the solar plus power backup plus far more efficient. All three things were getting. A 100-watt DC, and this is what my home had, can support 3 lights, 2 fans, a cell phone charger. 3 lights, 2 fans, a cell phone charger. And if you want a television, you have 1 fan, a television, a cell phone charger, 3 lights. The smallest home in India can manage something like this. We can add things. We can add a small refrigerator tomorrow and things like that. Of course, solar panels and batteries have to be appropriately sized. What is most interesting, and yesterday I was talking about, never do any of this work without first working on economics. And just to give you a picture, I took a typical home which has 2 tube lights, 2 fans, 2 bulbs, 1 phone, 1 television, running for 6 hours, 12 hours, 10 hours, 4 hours, or 10 hours. And you can change these numbers. These are simple Excel numbers. You can change them. And what is the cost per day, including the cost of depreciation and the interest for solar and battery, assuming grid cost will be 5 rupees per day. And I think this is a very, very revealing. Look at the number here for zero load shedding. If you go to a place like Bombay, where there is typically zero load shedding, what will a home like this pay per day? Cost per day works out to be 16 rupee 30 paise, about 500 rupees per month. If it was all done with DC, the cost will come down to 6 rupee 45 paise, about 200 rupees per month. This is assuming 5 rupees per unit grid cost. What if there is a 4-hour load shedding? This 16 rupees becomes 28, 29 rupees. Almost the bill goes to 900,000 rupees. You already see that a middle class home will find it difficult. Lower middle class home. Very small number. 2 tube lights, 2 fans, 2 bulbs, 1 cell phone and 1 TV. Whereas DC home, you are still talking about 220 rupees. What if it's completely off-grid, like in Rajasthan? This will go to 1,600 rupees. The one who are denied most and are the lowest income, things become the modern system become most expensive for them. I think Abhay knows more about it, he will talk more about it later about his health. But I think that's what happens here. Or probably anywhere else. But if you can put this system, you are still talking about 350, 375 rupees. And that's kind of economic. And always your initial assumed electronics should likely develop it. If you want to do that. You may not need that exactly, but it doesn't matter. You will then fine-tune it. And this is what we have been able to achieve today and we are able to do this. So it is a huge savings, reduces power bill, provides power backup. So in fact frees homes from load shedding and grid fault. Even in Varanasi, I thought that there is not much power. I talked to 3 drivers, all of them say about 2 hours of power per day. Very easily you can remove this and go anywhere further down because much less. Now, 2 points that I want to make. One, somebody came and told me, oh, you're working on a very small system. How will it make an impact to the country? Well, I said first, if it makes impact to the people of the country, it will make impact to the country. So that's the first answer there. Number 2, I said let's do the calculation. Suppose you put a 500-watt solar panel on every rooftop, not bigger than that. 500 watt would be about 3 square meters. The total power generated is 190,000 gigawatt hour per year, taking the Indian solar ratings. And that is equal to the power consumed in all domestic sector throughout the country. So a 500 watt solar panel more or less can free us from the grid. At least can free us to 80%. Grid should still be connected, still help us, but that's what we are able to. Then we actually shifted to buildings, our own IIT buildings, offices, research park, commercial complexes, and we started driving decentralized solar power to most of them. And again with DC loads, not just in powering appliances, but laptops, computers, air conditioning, cooling system, lifts and pumps. And we have been able to build systems which pretty much makes DC line in every office. Why? Because we use laptop, which is a DC power. Personal computer, DC power. A router is DC power. Display screen, DC power. VFDs, DC power. DC tube lights, LED bulbs, mobile charging sockets, sensors, exhaust fan. Where is AC that is used? Where is AC? Look for it. Can't find it. Why are we so stuck? Just because in 1890 somewhere in the world somebody decided that? And I'm not even talking about changing transmission, though that's another topic. But look at it. Leave the transmission as it. Can we inside our home and offices move to DC? And in apartment, offices, hospitals, educational institute, commercial complexes. One very interesting thing that we saw, and this is saw in our research park. When do we need the most cooling? When it is the hottest. When it is the hottest? When the sun is the brightest. When sun is the brightest, we get the maximum amount of sun power from sun. So solar and usage is a natural demand and supply match. Why we're not using natural supply match? And we started working on this air conditioning distribution system. And we have built air conditioning distribution system where we are able to reduce power consumption by about 40% straight away by using variable frequency drives on with AC motors or brushless DC motors and SR motors. And managing by finding out basically IoT, lots of sensors. But IoT has to be used in Indian context to help us, not just follow what is going on in the world. Water pumps, lifts, everything will benefit from DC motors or AC motors with VFDs. Again, you require most water when you should be able to pump most of the water when sun is there, or agriculture. But can we make it a cost effective? Can we make it so that it becomes affordable? I think that's the challenge that we have. I think more or less the last slide. Clean DC power homes driven by solar DC, power at affordable rates even during load shedding. Lower middle class homes can afford power even at subsidized rate. Will draw less from the grid or discount will lose less. Today they are losing. For even commercial buildings, it can save 30-40% of power. And this, if we do along with the focus that we already have on centralized solar, fairly easily we can get 50% of our power from solar by 2030. And I think that is what we are trying to do. At the same time, the second equal, more or less similar problem that we have been working on, and yesterday again I talked to the faculty here in power electronics area, can we get all our vehicles converted to electric vehicles? And power from sun. We took all the vehicles that exist today, took what is the growth, the best growth that anybody projects. We'll have about 400 million vehicles by 2030. We calculated, assuming all of that is electric, what is the power required? And what does it take to generate that? Suppose in state of Rajasthan, we take 0.5% of the land in Rajasthan, 0.5%, and put solar panel. 0.5%. it will generate enough power to power all the 400 million electric vehicles in 2030. That is the natural resource that we have. But we are turning away from that. We don't need oil. We don't even need nuclear. I'm not opposed to nuclear. No. Even coal, we can use it to less extent. And if we can do that, it's clean, and we can use it, our own technology, our own development, our transport sectors can completely change. And we have some. We always prayed for some. That's our tradition. And that gives us the energy. The question is, can we use it for our benefit rather than continuing on? We are very clear that by 2030 these two things will happen. We will of course need tens of thousands of faculty, youngsters working on R&D to do that. And we will get that number. We will of course have to align the government policy, and we will align it. We will of course have to get our industry aligned, and we will align it. I do hope that IIT BHU will join me in getting us there. India can become the most sustainable education. Thank you very much.
Thank you.